if I'm talking about the third normal form, so the relation or table is in second normal form, and all attributes in a relation schema are functionally dependent only on the key attributes. And this is a point you need to keep in mind. And there are so many points from which we can understand what is mean by the third normal form. So the relation is in second normal form, and all attributes in a relation schemes are functionally depend on the key attribute. This is the first point. If I was talking about the third normal form in more detail, then you can say it is an upgrade version of the upgrade part of the second normal form. And when a table or relation is in second normal form and has no transitivity, no transitive dependency. And this is the point you need to keep in mind in the third normal form. What we have in thermal normal form, your table or relation must be in second normal form and it should not have transitive dependency. Then it is called the third normal form. So this is the important definition from where you can start your third normal form. And let us discuss more about the more terms that is we have over here. A relation or table will be a third normal form if it is a second normal form and not contain any transitive partial dependency. It means no any kind of the dependency will be applicable in form of transitive. So if we have the transitive dependency, and that should not be applicable into the third normal form. Now question comes in our minds, what is mean by the transitive dependency? So we can say transitive dependency can be understood by the if x is depend by x is determined by and y is determinant to z, then definitely due to transitive dependency x will be determinant to z, and this is things which is known as the transitive dependency. And we have seen this kind of a dependency into the type of the functional dependencies. So that's why for explaining the so many things about the functional dependencies, I have already discussed what is mean by the functional dependencies, what are the various rules, what are the various types, and what are the various necessary of the functional dependency. So we have seen. Now decomposition we also seen. So all our terms are required to understand the concept of normalization. So that's why we have already covered all those concepts. Now the transitive dependency concept is clear to also we can understand what will be happen after applying the transitive dependency, and that should not be applicable into the third normal form. Let us continue. Third normal form is used to reduce the data duplication. So this is the point we need to keep in mind, and this is the biggest advantage of the third normal form. And it is also used to achieve the data integrity, and data integrity is a one kind of the feature or important part. And this is also important terms we have all discussed into the earlier class. We have seen what is mean by the data integrity, data redundancy, data inconsistency, data isolation, if you remember all those points. So it also used to achieve the data integrity. Uh, it means we don't have the duplication of the records. So data integrity or the integration between the all the data must be high. So this is the point we need to keep in mind, and this point or this thing we can achieve through the third normal form. So while you are looking for any development of the project, then a project which belongs to the database, definitely your database at least, or we can should be at least follow the third normal form. Then we can say now your project is having the good database. And in normal and regular project you are looking for, that is belong to third normal form. And if you want to upgrade your third normal form, then we have the Boise code normal form, and we will discuss with the level example. But before jumping on the Boise code normal form, so let us continue with the third normal. So if there is no transitive dependency or for non-prime attribute, so then the relation must be third normal form. So this is the fourth statement we can say. So all these terms are belong to the third normal form. So third normal form in a summary way you can understand. Definitely it is a kind of the normal form, and in which we can say the relation or table is known as the third normal form, which is having the second normal form and which does not follow the, or which should not have the no which should not have the transitive dependency. Then we can say now we have the relation or table which is belong to the third normal form, and this is a summary. And then we're talking about no transitive, then we can say the or for non-prime attribute. So now there should be difference between the attribute or key attribute or a non-prime attribute. So now prime attributes is basically are those attributes which can be used to make a super key or candidate key. So definitely we need to take care of this point. So with help of example, we will see. Yes. Let me know. This slide's content is clear to all. Yes, please tell me.
Yes, sir.
This. Okay. Here, mathematically notation you can say, and here I have just put it the content for you in simplification purpose, then you can understand. A relation is third normal form if it holds at least one of the following condition for every non-trivial functional dependency, and that is x determinant to y. Now again we have the definitely term definition part of the year non-trivial functional dependency. Of course, we know about the non-trivial functional dependency, and we have seen this kind of functional dependency with a lab example. We have seen. So X is a super key. So here we have two different attributes. This is the X and Y. So X can be the set of the attributes. So if you remember the terms in the non-trivial attributes, if we are talking about the non-trivial attribute, what happened in non-trivial attribute? Y will not be the part of the Y will not be the part of the X. If you remember the thing in the trivial, the Y will be the part of the set of the attribute that is X. Okay, so you're talking about this point. At least what is written over here? At least one following condition must be followed in the third normal form. So if you're saying that is X should be a super key and Y is a prime attribute for each element of the Y is a part of the sum candidate key. And this is the point we need to keep in mind. X is a super key. If you're saying over here X is a determinant to Y, then X is a super key and Y is a prime attribute. So if Y is a prime attribute, then each element of Y is a part of the sum candidate key. It means in the talking about non-trivial function, then we can say should not be like this should be not be the part of this one. But if you're saying this is a part, then we need to take care of this point. Each element of the Y is a part of the sum candidate key. And here we have the another question, that is what is mean by super key. So you can understand simplification purpose. A super key is a set of the attributes. A super key is a set of the attributes which can uniquely identify the tuple. Okay, which can uniquely identify the tuple. In super key, there is no guarantee all the row have the multiple copy. There is no guarantee it can have. But in candidate key is a super key. Candidate key is a super key. It means you're talking about the candidate key. It is a it is a super key, or it can have the property of the super key. But what is the thing we can say? By adding the zero or more attribute to candidate key, generate the super key. So in a candidate key, if you're adding one attribute, we are adding attribute one. Here we are adding more attribute, and with help of the these two different attributes, we are making the uniqueness in our record. Then we are following the super key. So this is the point. It is written into the summarized way. I am repeating once again to all. A super key is a set of the attribute which can uniquely identify the tuples. Okay, a candidate key is a super key. It means we can drive or we can find or identify which key which attribute will be the candidate key. So from the super key or set of the attribute we can easily identify. But how to identify? By adding a zero or more, by adding the zero or more attribute to candidate key, that is to generate the super key. So in a candidate key, you just add, you can add one attribute, more attribute, then you can make a super key. The super key can be derived from the candidate key by adding a zero or more attribute. So a super key can be the candidate key. Okay, I'm repeating my statement into different terms in the conversation. A super key can be candidate key, and super key can be the set of the attributes. And from those sort of the attribute, one attribute can be a candidate key. So this is the point. Yes. Any doubt here? Then you can ask me. Please tell me. Any doubt? This is the we are looking for the revision part right now because we have seen all these concepts. That's why I'm asking. Yes, please tell me. Any doubt here?
No, sir.
No, sir.
Okay, good. So let us take an example
Yes,
to
sir.
okay, good. Let us take an example to understand or explore the more detail about the third normal form. Here I am taking the simple table that is the employee ID, employee name, employee zip. Okay, that is a zip code, or we can say the pin code. We can say in India, and employee status, employee city. So these are the one, two, three, four, five different attributes which belong to the employee table. Now, in this employee table or employee relation, I'm right, take this one. In the employee relation, we have the 5 different attributes: employee ID, employee name, employee chip, employee state, and employee city. And from this point, you can say super key can be the set of the attributes. So you can see over here, or an attribute can also become the super key. So employee ID is also can be a super key. Yes, please tell me yes or no. If you haven't answered, so please let me know. Can we say employee ID can be a super key?
Yes, sir.
Okay, according to our definition, which is written on the previous slide, then you can say, yeah, of course, we can.
Sir,
Yes,
I have a question.
yes, now tell me.
Sir, super
Yes, yes,
key, can we have a single attribute? Only
yes,
single attribute?
yes, of course, of course, of course. It can have or it can have the multiple set of the attributes. No problem.
So
So now
means
see,
primary key is also a super key.
yes, of course. You if you remember the keys we have seen, first was the super key, then candidate key, and then you remember the primary key. So primary key can be becomes the set of the attribute, and we have done this thing by the practical. If you remember the practical part, primary key can be set of the 2 different key. It is also possible. So by default, all the properties which is having by the super key is also inherit into primary key. Into the primary key, the you are looking for the rows or attributes, and at least one attribute among the set of the attribute must hold the unique values. But in the super key, it can we can make the uniqueness into a row, but it can repeat the information. So this is a little bit difference we have to keep in mind. Yeah, of course we can
Or
say.
sir, what is about candidate key?
Since candidate key is basically nothing, it is basically a subset of the super key, you can say. So by default, in every table, in every relation, every attribute belongs to the candidate key. Like employee state is also becomes a candidate key. But with the help of the employee state, you can't define that as a this is a key because it can have the multiple copy or redundancy. So definitely we can say it cannot be candidate key, but it is a candidate key, but you can't justify. And if you want to justify, then you have to take an attribute which provide the uniqueness. But we are choosing the employee state. UP, USS. So US coming 2 times. So with this value, we can't distinguish it. That is a this can be a key attribute. So this is the point. So now see the super key can be generated by the 2 different attribute. Those are the employee ID, employee name. Now see, and employee ID, employee name, and employee j. So of course, with the help of the these 3 different attributes, we can make the super key, because super key is nothing which is set of the attributes. And from this point, employee name can be same, employee chip can be same, duplicacy. But with the help of the employee ID, we can distinguish. So we can make the super key with help of the 3 different attributes, but at least one attribute should have the unique value by which we can distinguish. So through the employee ID, we can see. Now, employee ID, employee name. So from this point, employee name can be have the duplicacy. There is no issue. Ram, Lakshman, or Ajay, and Meena, Zina, and so on. So comes many times. But with help of the their employee ID, we can distinguish who belong to the whose name. So we can identify. So at least one attribute is required to make the distinguish. Yes, of course. Employee JIP or employee name. Yes, employee JIP or employee name can be super key, but with help of the employee JIP, employee name, we can't see. How we can see? Why? Because 2 employee belong to the same city, 2 employee belong to the same or having the same pin code number. Then how you can justify this one? So at the time, super key cannot be part of this. So you can distinguish, you can identify the uniqueness. This is the point. And suppose we in our 60 student, all students belong to the different city, but there may be some chance of two more than 2 student or 2 student can belong to the same city or same pin number. Then how you can identify? So we can't have the uniqueness into the our table. So this is the point. So super key in the our table we can have the employee ID only. Of course, can be employee ID, employee name, employee ID, employee name, employee JIP, and of course employee ID, employee name, employee JIP, employee state, or employee city can be a super key. It is a set of that. or single attribute also become the super key. Now in the candidate key, you can remember this is the only key which is completely defined, that is we can represent entire record or set of the record into the uniqueness by putting the employee id. So this is the candidate key. So this is the candidate key by which we can say, but employee name can be candidate key, no, because Harry Stephen may be coming 3 years or 3 years or 4 times or 5 times coming repeatedly again and again. So it can't be. Okay, it can't be candidate key. So candidate key can be a key attribute when it represents the uniqueness. But employee name by the employee you can't. By the employee job you can't. By the employee state you can't. By the employee city you can't. So this is the point. So definitely in this table we can say employee ID is the candidate key, and a primary key definition is saying to us a primary key is a key which is a candidate key and represent the uniqueness in your record in your table. And this is the definition of the primary key, if you remember, as we have seen. Now, any doubt in this table? Yes, please tell me. We have discussed about the
Sir,
keys.
suppose we have a employee email ID in this table, then it
Yes,
is also
yeah.
be candidate key.
Yes, sir. At the time, if we have the employee email ID, you're talking about email, okay? Am I right?
Yes, sir.
Okay, so you're talking about the employee email ID, not employee ID. So at the time, the employee ID becomes the candidate key. So here in this case, we have the two candidate key. That could be the employee ID, and that could be the employee email ID and employee ID. So at the time, we can have the two attribute by which we can differentiate. There is no issue. But this is a since this is a point, there will be less chance. But suppose an employee does not belong to the does not have a right now employee ID, and it is not a mandatory field. Okay, it is not a mandatory field, and he is just putting the official email ID at the time. So at the time there may be some chance. There may be some chance and two or three employee having the same employee ID officially, because they right now while joining the organization they don't have. So there may be duplicacy. So, but if they have the employee have, at that case they can represent as a candidate key. So this could be the part of the candidate key, and candidate key now transform to composite key while we are looking for the two set of the attributes. So super key can also be transformed into the composite key while we are looking for the uniqueness into the record. So it's up to you. It's based on the table data, what the information we have on from such information we need to identify the key attributes. So of course we can have. So employee email ID can be, of course. Yes, I agree with this point. Yes. Now this is the information clear to all about the this table.
Yes, sir.
Yes,
Okay,
sir.
good. So I'm just moving to the my next slide. So let us clear the few things from this relation, then you can understand. And if you have to remember the few things in your mind: employee ID, employee name, employee GIP, employee state, and employee city. So now non-prime attributes. As our definition is written into the third normal form, what is written over here? If you remember the term, if there is no transitive dependency for non-prime attribute, the relation must be in the third normal. Just see the last statement. So if we're talking about non-prime attributes, so what is sense of the non-prime attribute? So through the our example, we have the few attributes by which we can say. So in our given table, all the attributes except the employee ID are non-prime. Non-prime, because non-prime means it does not belong to the any kind of the key attributes. So here employee state and employee city depend on the employees, of course. If you want to put the detail of the employee city or employee state, so we can put the employee in Egypt. So something is depend on something. So or some information maybe depend on the some kind of the attribute. So depend on the what kind of the attribute we are having. So we can say drive attribute, multiple attributes, so different kind of attribute pattern we have. But right now into our example we can say employee state and employee city is depend on the employee. You are putting the different kind of the employee zip, and employee state on employee city you are having the different. So definitely your data is mismatched. Actual fact is mismatched. For the understanding purpose, you can put anything, there is no issue. X, Y, Z you want to put, you can understand. But if we're talking about the actual fact, now Bhopal is a city which belongs to the Madhya Pradesh state, not Uttar Pradesh state. So now I'm just writing the foundation of Bhopal and Uttar Pradesh. So this is a wrong fact. But I'm talking about the actual fact. Then Bhopal belongs to MP state. And of course, if I'm putting the something like any zip number like 5467 something, so that is not a feasible. That is not actual. So according to the this logical concept or according to the actual fact, we can say the employeeship is basically is an attribute which is required to define, required to explain the employee state and employee city. And same thing we're talking about the employee. So employee is depend on the employee ID. Why? Because employee ID is an attribute which defined at the employee name, okay, which belong to the employee name. And if you need to identify the employee who belong to which employee, oh, sorry, who employee belong to the which city. So definitely we just need to take care of the employee job. So employee job is a field or attribute which belong to the two different paradigms. One is an employee detail to finding the employee detail, okay, and to finding the employee city and state. So we can see over here the non-prime attribute like employee state and employee city, and that is transitively depend on the super key, and that is what we have the employee ID, and it violates the rule of the third non-form. And in according to our definition, transitive dependency will not be stacked. If we are having the transitive dependency, so we can't have. So let us make the diagram over here, then we can understand. Employee state and employee city is depend on the employee job. So I'm writing over here. So these are the two attributes which are depend on the this. And now if I'm saying to over here, employee job is depend on the employee job is depend on the employee city. So I can write this diagram over here. Uh, Employee state, comma employee city is depend on the employee job. So this is a one kind of the dependency I'm writing. Second dependency is saying to us employee job is depend on the employee ID. So employee ID is determined to employee job. Now see this dependency and see this dependency. After seeing this dependency, we can easily find the transitive over here, and we can say employee state, employee city is depend on the employee ID. So from this dependency, we can say employee ID determinant to employee state and employee city. And this was the rule of the third normal form. So that's why we need to move the employee city, employee state to the new employee job. Okay, table. So we need to create another table and with employee job as a primary key. So we need to take care of this point by the example. Now see this example. Now first what we are doing, we have the employee ID and employee name and employee job. So this is the point where we have the new table, that is employee table, and we need to create another table from the existing table. And what we are doing the decomposition. And after performing decomposition, now you have to remember the point over here in the second normal form, we have to do decomposition. So of course we are talking about the third normal form, so decomposition will be applicable over here. And now here the employee job. So you can see over here employee job, employee state, employee city. So what we are doing, we are just dividing or decomposing the our thing, our relation into the two different tables and to see whether the rule is violating or not. So that's why we need to move the employee city, employee state into the new table, that is employee job table, and this will contain the entire detail. So this will contain the entire detail. Now from this record, from employee job record, we can say each and every record belong to the uniqueness. And here in employee table, we can say we have the uniqueness also. But here, employee chip is can be we can say depend on the employee ID, employee name. So as we have seen to the over here. So employee ID, basically what we are seeing over here, employee state and employee cities depend on the employee ID. So ultimate through the transitive approach we are finding, and now what we are doing from this point, we are violating the rule, and to avoid the violate the rule, what we need to do, we need to decompose our relation into the two different relation or more than two different relation as our required. So why we are doing the decomposition over here? Because in our this relation, in our this relation, we are founding that there is a transitive dependencies available over here. And how we can identify from this relation after applying the function dependency approach, and we found that employee state employee city is depend on the, it means these are the two attributes which are depend on the employee jib, and employee jib is also depend on the employee id. So finally what we are getting, that is the transitive is applicable over
Sir,
here.
employee
Yes,
means?
employee
Sir,
jib pin code
employee
number,
means
pin code number, pin code,
pin code number of
the
what? Area pin code number?
city or area pin code number.
Okay, sir.
And in US and foreign country, we use the word zip code, or in our India, we have to use the word pin code, and there is nothing difference. Both are same. So, what we are doing in this relation, it is founded. What we are having, the transitive dependency, and to see this is a transitive dependency, then we need to break or decompose this relation into two different relation. And what is the common thing we are founding? We are founding the employee jib, and so we will take employee jib as a common attribute. So finally we did this activity over here. So now we have the two relation. One is employee, which contains the employee id, employee name, and employee jib, and then employee jib, employee state, employee city we have over here. And now, if we need to retrieve the actual table, then definitely what we need to do, we need to perform the join operation and followed by the employee jib, which belong to the both relation, that is the employee jib. So we will get the original table. So here, after decomposition, if we are getting the original table, so definitely we are having the lossless decomposition. And now, if you are doing the decomposition, it means we are following the, or we are having the idea or concept of the second normal form. In the second normal form, if we need to do thing, then we have done the decomposition. So this is the part which is known as the third normal form. In third normal form, I am just clearing to all once again. In the actual travel, you need to see which attribute is depend on the other attribute. If it is depend on the other attribute and is found that we have the transitive dependency, then we need to decompose. Okay, so why we are decomposing? Because to simplify the, or to normalize the our relation, and after normalization relation, so we performing the third normal form. So every time you need to check is it applicable or not. If it is applicable, then we need to break. So here we are doing the over here. Yes, please. Now tell me, is it clear to all? Yes, please. Is it clear to all?
Yes, sir.
Okay. Okay, good. So I'm just having another example over here, and now I'm just leaving right now this example to all. This is a same example. I have added the new thing, which is the employee district, and this from this point you need to identify. From this point you need to identify which the third normal form and how to simplify the third normal forms. Yes. So employee ID we have same as it is employee name, we have employee JIP, we have also employee state like UP, Tamil Nadu, UK, Uttarakhand, MP we have. Employee city I'm just putting over here the Agra, Chennai, Pauri, and Gwalior, and the district employee district means some area of the particular city. So in the Agra, the student who belong to the Agra, they know about the Dialbag area, and those students who belong to Chennai, so they know, they are familiar with the term about the MCT and Purapakkad. Okay, they know well known about these areas. And if it's talking about the forest city, so Bhagwan is just kind of the place we have. Okay, so and those students who belong to the Gwalior city, so or employee, so they belong to the some area that is different kind of the colony or to Ratan colony, just like the place we available. So here we have some data which belong to employer student, you can say. And from having seen this relation, you need to identify, is it Yes, we have the transitive dependency, and if we have transitive dependency, then we need to decompose. Yes, please. Should I explain here, or you will understand, or should I leave right now? This exercise one.
Sir, I want to ask something. Sir,
Yeah.
is this transitive dependency occur between three attributes or more than three?
More than three. It can be more than three, or can be three. Depends on the your relation. Okay, depend on the relation you need to find.
So, sir, here can we say this employee city, employee state, and employee district? These all three uh, transitively depend on employee zip. So we will remove these three attributes at the last.
Okay, according to what you are saying to over here, employee city, employee district, all these are depend on the employees.
Tran Yes, sir.
Just like
So
the
we will
just like
remove these all three.
yeah, just like previous example. And
Yes,
this
sir.
employee GP is depend on the employee ID to find the employee name and the details, and to determine that is whose employee belong to the whose city. So definitely we have this point. Of course, this is the dependency we
Yes,
can
sir.
have now. So super key we can just find just like the previous example. This could be, and a candidate will be the employee ID. Same example we have, just what we have. We have just added the employee district, nothing else. A non-prime key attribute. So you can see over here, employee city, employee state, employee district. According to you, same here we have. This depend on the employee job. And employee job is depend on the employee ID, so that makes a non-prime key attribute, and it violates the rule.
Sir,
Okay. Yes.
prime key means unique चीज, मतलब
Yes.
unique ID.
Yeah. Yes. Prime key means an attribute which has the at least uniqueness to in entire domain. So just like the only employee ID, that is a attribute which belong to the prime attribute. It means key attributes.
Okay, sir. Understood.
So here the same example we have over here. So from this example, we can found how many tables we have. Of course, there will be the two table after decomposition. That is the employee name, employee chip instance. Yes. Okay. So employee ID, employee name, and employee chip we have over here. Just like the previous example. And we got the new table that just like the employee chip as about the previous example. Employee district will be employee city, employee state, employee chip. So while decomposition, let me clear to all over here. While decomposing, while decomposing, you need to take care of this point. At least one common attribute is required. Why one common attribute? If you want to get original table from the decomposed relation or decomposed table, we will get the actual information. So we will not lose any kind of the information. So we are not having the lossy decomposition, we have the lossless decomposition. One common attribute and uncommon attribute, and it must have the lossless decomposition. Lossless decomposition. Lossless decomposition. So definitely this would be the our answer. This would be our solution. Yes. Yes. Tell me any doubt so far?
No doubt, sir.
Is it clear to all about the third normal form?
Yes, sir, it's clear.
Yes, sir. It is clear.